Good morning, good afternoon, everyone, and welcome to this second episode of Delta Dialogues. Today we'll be broadcasting live from the Hannover Messe in Germany, where we are present with 4 of our partners on 2 Dutch pavilions. My name is Johan Smees, and I will be your host today. Before I will introduce you to the program and the speakers that we have lined up for you, I would like to ask you to ask any questions you might have in the chat, so I can revert them to the various speakers that we have lined up today. Also, for the ones that are calling in for the first time today, Photon Delta Dialogues is there for you. So we are a community call every month, the first Wednesday, in order to give almost relevant updates from the community, from the ecosystem to you. You can also send in your contributions. You can send in your questions or any presentation that you would like to do, and you can do so through the website. If you go to the website of photondelta.com, you go to the event sections, you will find the Delta Dialogues there, and you can tune in and send in your presentations. So today we have a couple of nice presentations for you. We will start off with an interactive discussion with Ivan Stojanovic from OostNL. We will discuss more about the next gen growth proposal, which was also granted together with the Photon Delta proposal. Understand better what that proposal is about and the link with integrated photonics too, because there is a link. Second, we have the usual Who is Who, where we have a couple of pitches from startups from the ecosystem. So today we will start with Marangelo Petrozella from MantiSpectra, a nice spin-off from the Eindhoven University of Technology. He will quickly tell you about what they are doing, their developments, and their vision for the technology that they make. Second, we will have Pim Kat, who started his startup together with Ton Bucks. That's called Amazec Photonics. He will tell a bit more about what they are doing. And then finally, we will listen to Eduardo Margallo from Ommatidia Lidar and see what they are doing over there as well. So as I said, every time you have the opportunity to interact with the speakers, just do so by dropping the questions in the chat so that I can pick them. After the Who is Who, we will have a keynote, or well, more of a keynote. It's actually a Q&A, an interactive discussion that I had with Nick Singh. He is the new CTO of PhotonFirst. And Nick has a very interesting background also in semicon and in various organizations that he led the technology development. So we are very curious to hear more from him on his experience, his insights into the integrated photonics industry, and what his vision is with PhotonFirst and how to collaborate with the rest of the ecosystem. So with no further ado, I would like to go and start with Ivan Stojanovic. Just one thing, this is the first time that we're trying to do a mobile setup at the Hannover Messe, of course. So we have some technical things that I have to work with. So bear with me. I will start. 1 second. Here we go. Okay. Hi, Ivan. Good afternoon.
Good afternoon, Jorn. How are you?
I am good, thank you. How are you doing today?
Very good. It's nice to see you again, and it's always good to see some good, friendly colleagues that we always interact with. So it's a good day, and let's hope that it will keep this positive energy going.
Yes, exactly. I met one of your colleagues yesterday here, or your colleagues, people from the Next Gen proposal. They were here yesterday to celebrate a moment which was dedicated to the robotics section. But Next Gen proposal, maybe you can tell us a bit more. First, what is the Next Gen proposal about?
Well, first of all, it's of course great that we got a couple of very, very ambitious and very good and relevant proposals that were granted in the second tranche. One of which, of course, is your own that you have been working on with Photon Delta, I should say. And ours is Next Gen High Tech, which is a very nice, beautifully complementary growth fund proposal that actually intersects nicely with the Photon Delta proposal and supplements and complements it in key areas. So as you know, of course, the Dutch industry, the Dutch high-tech industry has been a leader when it comes to developing high-tech devices and tools and machines for already a long time. And so with this Next Gen High-Tech proposal, we want to not only sustain this energy and maybe kickstart it into a higher gear, but actually have it continuously have a leading position. So what we have with Next Gen High Tech is a proposal that actually tackles many different key areas, many different areas of application. So for instance, laser SATCOM, energy conversion and energy storage, bio-nano, so biomedical production, but also what we call semicon, or rather heterogeneous semicon tools. So that means that there is an explicit need for the developing of next generation tools and devices that enable these next generation systems and chips. So one of which is, of course, photonics chips, but more importantly, the heterogeneous integration of these chips in all sorts of complicated and next generation systems that we will sure be seeing in the next decade. But we're also doing this on the other domains, like, for instance, agri-food, where we need harvesting machines that are able to detect if a particular type of fruit or vegetable is ripe for the picking, and what is the condition and how long it still has to go, for instance. But also a flexible microfactory for composites, for instance. So we've got a range of different topics. But what is beautiful to see from standpoint of view of photonics, there's a couple of domains that are explicitly trying to tap into the knowledge that Photon Delta, or rather the photonics ecosystem in the Netherlands, has. So it's a wonderful complementary proposal.
Great, yes, indeed. And so, okay, I understand there's a lot of different topics that are captured within the Next Gen High Tech proposal, right? And just for the understanding of the audience, how much are we talking about in total here?
So we're talking about a proposal that has right now ready to go 340 partners, of which are 189 SMEs, 89 SMEs. So 189 small, medium enterprises that really have unique sets of skills and knowledge to really make this next generation happen. And of which, of these companies, 75 are start and scale ups. So there's also a very nice stimulus for these companies to continue their path towards growth. And right now we have 42 concrete project plans that have been worked out. And the budget that we're working with right now is, give or take, 450 million euro.
Incredible. That's good. Great.
That's from the point of view of the growth fund only. And of course, that does not include the private investment of the company. So actually, give or take, about 1 billion.
Oh, all right. So that's actually well, very similar to the scope, or let's say the size of the project from Photon Delta.
Yeah.
And you already mentioned a couple of areas of, let's say, overlap or synergy with the integrated photonics industry. Maybe you can elaborate a little bit more on that.
Well, so if we're looking specifically at photonics, we got a couple of application fields. For instance, in laser SATCOM, which wants to develop their next generation tools for, or not actually tools, but data communication through light and laser satellite communication. And for this, we need integrated photonic, components. And the nice thing is there are several projects in that domain that explicitly use and include some of these core competence companies like Lyonics, like Smart Photonics, but also, for instance, the backend packagers like PhotonFirst and Fix, that really try to make these tools come to life and these next generation machines come to life. When we look at, however, for instance, the semicon domain, we very carefully try to carve out, okay, where is the need for the next generation semicon? And, not to step on ASML's shoes, but next generation semicon is not just EUV or EUV2 or, the next generation. It's also, the heterogeneous semicon. So how can we combine various types of semicon technology, various types of chiplets into one functioning module or package, or maybe even on-chip design. And for that, we need to have new production tools, metrology tools, testing tools that are able to test these disruptive chip technologies like integrated photonics. And before we start to use them and package them in modules, we need to know what are the specifications, do they work, and under what circumstances? And then, of course, what's the most efficient and effective way to package them? So we're focusing on developing those tools in conjunction with what you are doing, which is process development and knowing where these chip companies in your domain want to go towards, which targets they want to achieve within the next 7 years. So we carefully carved out our roadmap so that our tools that we will develop will support that roadmap of these companies, but also of the high-tech industry in the Netherlands.
Yes, I think that's a very important activity actually, because as you already mentioned, it will really complement or enable actually the photon delta plans also to be executed. Because without the right machines, without the right tools and metrology systems, we won't be able to do that.
Yeah.
One of the areas that you just highlighted is the heterogeneous integration, for example, and packaging, so the back end of the supply chain, and that's right now actually one of the big bottlenecks. Is where a lot of time and costs are. I think in the past we had let's say a smaller project that we launched also with Fix, with Tegema, now Etteplan, PI as well, instruments, in order to enable that. But of course, there's a lot more that needs to be done there to let's say make the right machines that are specific for this industry. But without that, we won't be able to scale up actually.
Yeah, absolutely. And that will also hinder the promise that integrated photonics and heterogeneous systems have. And I think that's a key role that we in the Netherlands can, take and have and own. Doesn't mean that we will not include our foreign partners and make it grow with them, because we have to do this together in order to make it a strategic alliance for the future. And that also means, for instance, not just machines and tools, but also facilities where these chips will have to be made. So these are logical, incremental, stepwise investments that we're trying to achieve. And if you tick one box, you have to already know which other box you want to tick. So it's a logical system.
Yeah, no, exactly. And also, I think one of the misconceptions that people have is that there's one platform that's going to do it all, right?
Yeah.
And that's really not the case. What we see in the industry right now, and especially when we look at the markets that want to adopt this technology, is that they need to mix and match platforms in order to get those functionalities that they need in order to serve their customers. And that's also why this heterogeneous integration is of course important, not only because you need to mix different photonic platforms like silicon nitride with indium phosphide, but you also of course always need to have some sort of electricity source, right? You need to have some sort of electronics integrated in that. So that makes it even more important. Maybe another question would be on right. So when this project is going to start, how can companies? I mean, what I experienced here on the Hanover Messe is that already quite some companies came to me and they ask, oh, so we heard about this growth fund, Photon Delta, next gen high tech. How can we do to collaborate? Can we also join the movement? What do you have to say on that?
Yeah, well, that's a good question, and it's of course always good to have positive energy. The thing is that we try to organize the next gen high tech proposal in several ways and forms. We have a couple of depths and layers that we're working on, not just the domains that I just mentioned, but we also work in what we call the application domain and the more like a theoretical domain, but more like a in-depth domain of developing the knowledge. And the application domain has more or less already the defined projects, and they have been already lined out for the next 5 to 7 years. Whereas in the theoretical, in the investigative domain, there are projected to be open calls and open call structures, NWO type open calls, where companies can propose some of their research, which is a little bit more of a shall we say, elementary or in a very lower TRL level, that still is very important to make, even though the next generation machines are coming, it makes the next generation also come into view. So we have this more lower TRL level open call domain that we want to collaborate on with various different partners. The key is, of course, that these consortia have to have the Dutch element in there, which means that you have to collaborate with our companies and with our entities, but it does not necessarily block foreign companies and other parties to enter. Especially in a collaborative setting, it would be very nice to have this dynamic and have this energy. So when it comes to trying to join the project, I would suggest that people can contact me or send me an email or whatever, and I can see how we can hook this up. And when it comes to when it gets started, so we're right now working on finalizing some of these last little parameters that we had to change. And it looks like that we will submit a final proposal somewhere around June, July. Doesn't mean that it will be reevaluated. It means generally, okay, we ticked all the boxes that we needed to tick, and that means that the project will be able to start and kick off towards the end of the year, somewhere after October.
All right, good. And are you looking at these partners there, these companies to contribute? Are you looking at mostly hardware companies, or is there also room for software companies?
I think this is regardless of which platforms we're talking about right now, hardware, software, or whatever. I think it's very important that we design these machines smart and clever and flexible and modular. So that actually does require both of these competences. So hardware, software, also more of a knowledge institute type collaborators. Absolutely everything is open and welcome for us.
All right. Good. So there was one question that came in through the chat right now. If people want to learn more about this project, the website is in Dutch only. Are you guys planning on doing also maybe an English version?
Absolutely. As far as I knew, it was also available already, but there are already some English documentation. So I would say to the people that want to contact me, please send me an email. I don't know if it's better if I would just write the email down in the chat or if I mention it here. Anyway, it's ivan.stojanovic@oostnl.nl. Not the easiest name in the world, but I'm sure Jorn will be able to forward my email to you. Other than that, there's the website on my side here that you can visit, and yeah, we will absolutely launch it multilingual so that other parties can also read and catch up on it. But if it's not yet available, please contact me and I'll be more than happy to inform you.
Okay. Thank you, Ivan, and thank you very much for your discussion today. I think there are no more further questions, so we can go on to the next part of this program. Thank you again, Ivan.
Have a good day and see you next time.
See you. Okay, so here we are at Hannover Messe, and next to me is sitting no one less than Maurangelo Petruzella from MantiSpectra.
Hello.
As I already said at the beginning of this episode, so Maurangelo is from MantiSpectra. It's a very interesting spin-off from the Eindhoven University of Technology. They are here with us at the pavilion. I think your booth is creating quite a lot of traction. There's a lot of people visiting, asking questions, so great job.
Most visited stand in the pavilion, probably.
Yes, yes. I think so too. And Maurangelo will be here to give you a presentation about MantiSpectra and tell you more about what they are doing with their products. So let me see if I can share the screen again and continue to his presentation. There we go. All right, Maurangelo, the floor is yours.
Thanks a lot. Hi, everybody. Well, it's a pleasure to be here today. As Jan mentioned, we are extremely excited to be in Hanover. So if you are in this area, feel free to visit us. We are at Hall 2, Stand 20. And today we're going to talk a bit about our technology, what we have done in the past few years. Here you see already a picture of our spectral sensor, as we call it, chip sense. A very tiny, well, photonic integrated chip that allows us to measure material properties without sending samples to a lab. As you see, it's very tiny. And most importantly, we measure near-infrared radiation, and based on this radiation, we are able to understand the type of materials, and we also understand what is inside materials. So I have a 5 minutes presentation. I will be very briefly, how to go? Okay. So essentially, what we do near-infrared spectroscopy on a chip, right? And this is a technology that existed since actually 20 years. It was based on large instruments, 1 meter big instruments, very expensive instruments made of many parts. And actually, what we have been doing at our university a long time ago, a few years ago, was to integrate a full spectrometer on a chip. So it is the only integrated solution on the chip on these wavelengths. And differently from a bulk instruments, we don't have any moving parts, anything that is actually co-packaged. Everything is packaged at the wafer level. Everything is monolithic. And this is really a potential for scale up into volumes and to reduce the cost of this sensor, to enable new applications, these sensors, also in new domains where near-infrared spectroscopy was not used. Here I see here, I think we missed one slide, but essentially we have, it's at the end. Okay, we just skip one slide.
There it is, yes.
Essentially, what we do in near-infrared spectroscopy, well, as I mentioned, we do two different things. We can classify materials using light, or we can quantify, again, matrices, what is inside materials. And this technology is already used in many different segments, many different industries. And here you see 3 different examples. For example, it is used in smart farming to measure ripeness before harvesting or after harvesting, to measure, for example, material content like protein directly in tractors. Also, we are involved with what is called IoT industry, essentially to unveil a layer of data from materials to enable traceability of system, as well as identification of raw materials. And also there is an upcoming new, let's say, new applications in the domain of, for example, home appliances, where many companies are currently validating our sensor to test, for example, food and drinks, or to classify different types of textiles for washing machines. So there are a plethora of new applications where we see this sensor will make a really big difference also in the consumer space. And the main idea is, again, very simple. Your speaker is still, okay, it's the essentially we have the idea is very simple. We have these very fast, contactless, low-cost measurements of material analysis, again, without requiring our customers to send samples to a lab. So with a clear advantage in terms of price and in terms of time that they spent in doing this analysis. Now maybe I can go back one slide.
Yes.
So this is, as I mentioned, we developed this new chip technology, but also as in the previous speaker, we were talking about co-packaging and the complexity of adding this co-packaging functionality to develop modules. This is something that also we have done, and actually we have developed what we call Spectropod, that is a development kit which has everything included. So it has a light source, electronic, and chip sense, and actually our customers are already using this development kit to start collecting data, to start to building the brain behind, let's say, the technology, because the chip is only one part of the puzzle, but also attached to that, there is also the brain, the machine learning model that we need to connect. The need to connect the raw data directly to the answers, to the final answers that our customers want. So in terms of key parameters that they want to measure. As you see here, we have different flavors for this development kit. We have what we call interactance, reflectance, cuvette systems, and also possibility to couple to a fiber for process control. If you want to have more information, you can just contact us. Maybe we can share later on our email directly. You can reach out directly to me. And also we can customize also this different configuration for the need of our customers. I think this probably concludes my few minutes talk. Again, feel free to reach out to us directly via email, or if you're in this area, we are at Hall 2, stand 20. happy to understand if we can solve your applications or if you want to develop new products where you see potential to use spectral intelligence to do new things.
All right, thank you very much, Marangelo. It was a very interesting presentation. I think we have one question popping in from the audience, so let me quickly take a look. What kind of light source do you use in your system? Is Tobias asking, Tobias Harter.
Yeah, absolutely. We are currently using a standard lamp to do well, spectroscopy, very calibrated lamp, and it's very standard and low cost.
Okay, but it's, if I understood correctly, it's near infrared, right?
It's near infrared. So the main difference compared also to other technologies that we measure about 1000 nanometer. And this is where, let's say, all the juice, all the chemical information is encoded, right? Other technology measure the visible and they're based on silicon. And there are clear limitations in the number of applications that you can develop on the silicon-based technology. So there is where actually our platform plays a big role, and in terms of light source, we are using a broadband small lamp that allows us to measure in this spectral range.
All right, good. Thank you, Marangelo. I think there's no more further questions. If there are, I will put the website and your on the chat, so people can reach out to you through the website. Thanks again for your time, and I wish you a good further continuation of the Hannover Messe.
Thanks. Thanks, everybody.
Okay, so our next speaker for today is Pim Kat. Pim Kat is recently started a new startup. You might know him from PhotonFirst and Technobis. He was the founder of Technobis, and then eventually that became PhotonFirst in January. Pim Kat, we recorded his presentation just to make sure that there's no technological delays, but he's here live in the session as well, so you can ask questions and he will be able to answer them to you later. We will start with Pim's presentation right now. Enjoy.
Okay, well, I like to tell a little bit about the development of Amazec Photonics and how we came to a complete new way of sensing in a medical device. So the first slide is about when we started. We were asked by ASML to measure very high resolution vibrations in the wafer table. And we needed to measure sub-nanometer amplitudes of the table with strain sensors. Next slide, please. We measure with fiber break ratings. It's a sensor inside a fiber, and we can measure wavelength shifts when the fiber elongates by temperature or by a mechanical strain. Next slide, please. This is the roadmap that we had in 2010, reaching this incredible resolution of 0.1 femtometer wavelength shift. We started with spectrometry and changed over to integrated photonics Mach-Zehnder interferometry, and the complete system was successfully demonstrated in 2014. The same technology, the same chipset is now used for measuring high resolution temperature in blood systems, human blood systems. Next slide. So the method that we use, the medical method, is to inject a cold fluid in the blood system of a human. It goes through the heart, it is pumped through the heart. And on the outside of the heart, we measure a very extreme resolution of temperature. System we are aiming for is measuring 0.1 microkelvin. Next slide, please. So this is typically what is called the indicator dilution curve. You see the temperature drop of the blood after it passes the heart. And if you have a good functioning heart, it passes very quickly through the heart. If you have not so good functioning heart, it takes a long time for the heart to pump the cold fluid through the heart. Next slide, please. So to our surprise, when we were measuring with the very high resolution system first time, we saw that that we had multiple passes of this cold fluid, and that was really surprising that the cold fluid, only 10 cc of cold fluid is passing through the whole body and returns through the heart. But this is measured multiple times, and yeah, it seems that this cold fluid is still more or less intact, going through through the main blood systems of the human system. Next slide, please. We built a simulator for the complete blood system of a human body, and also in this simulation you can see that the cold fluid is recirculating through the whole body. So these are curves of the first pass, a very steep curve, and then the second, the third, and even the fourth pass through the human heart. And this indicates that by measuring the pass through a heart, and you can even see the separate heartbeats in the curve. You can calculate the flow of the blood through the heart, and by multiplying that by the time it takes to get to the second pass, you can calculate the total circular blood volume in the human body. And that is something that is completely new in the medical systems. There's no way, except for a very expensive and very critical a method with ionized what do I have? Iodium, yeah. But this is a way to measure with temperature of the heart within a couple of minutes what the total circular blood volume of a human body is. Next slide, please. So recirculation is seen after about 30 to 60 seconds, depends on the human body, the weight of the body, the type of person you measure. But this feature is completely new, and we patented the whole system. Next slide, please. So the business case that we see is, first of all, a complete new system for indicator dilution curves, replacing the high resolution systems that are out there. We think that we can, in Europe alone, directly assess a market of about 5,000 systems. And the extra feature is to measure the total circular blood volume. That is very important to know if a patient lost a lot of blood, for instance, in an accident or birth or other medical operations. So we can measure it within minutes, and it can be used basically by not trained medical employees, so it doesn't have to be a surgeon doing the measurement. So yeah, that's what we were working on since 2019 already, and we hope to have the prototypes ready, or the first functional model ready end of this summer. Thank you very much.
All right. Well, that was a very interesting new application for us, Pim. Thank you very much for your presentation there. I see that some people are very excited about this presentation too. Shahant is saying this is brilliant. Are there any questions for Pim? Or maybe Pim, you can also unmute yourself. Oh wait, I'll have to give you those rights quickly. Allow your microphone, allow your camera, so you can maybe unmute yourself and put your camera on, so we can actually see you and hear you. Hi, Pim. There you are.
Good afternoon. Hi.
Okay, so I think this is something that we did not expect to be able to measure the blood volume, the circulating blood volume, by using integrated photonics. It's a very new way of using fiber optic sensing. So great job on that. What's the current status, if I may ask? So you have the business case. You're developing the technology. Can you maybe tell us a little bit more?
Yeah, well, let me first say that I heard my own presentation now, and there was one mistake. I was talking about 0.1 microkelvin, but actually it's millikelvin, a range that we measure. That's already a 1 femtometer resolution wavelength measurement. So that is more or less, I think, extreme. Well, the status at this moment is that we are testing the temperature sensors. We are building up the functional model basically from components that we developed for ASML in the past. So it's not new, it's not research, it's combining things that we already did before. And basically finding now, because this project is already 10 years old, or the technology is 10 years old, looking in the market if there are more basic components like the laser driver, but also on the sensor side. What's new, and of course our competition didn't sit still, so probably we can buy more standard stuff than what we did in the past. So
right. Yeah.
And basically that we know that there is a certain price range for these kinds of systems. So we cannot come up with a system that costs €500,000. Nobody will buy it. So we have a very steep target for the price of the system. And we think we can reach it with the right partners and the right standard technology now.
All right. I see there's one more question that popped in from the chat. Tobias Harter is asking, how is the fiber attached into the human body?
Yeah, it was in my slide, but one of the ideas is to just measure on an artery on your pulse, in the neck, or in the human body. But the best way to measure it is to do it with a probe in your a probe that goes into your throat, and it comes very close to the heart chamber, and that's probably the best place to measure. But if we do that, you have to go into the body. For medical use, the lungs and the esophagus is still considered to be outside of the body. So it's not invasive what we do, but it's easier to just put the sensor on your pulse and measure there. And by measuring by this resolution, you can see it pass, because that was basically what we did in the first trials. See if we could inject on one side of the body and measure on the other side, on the other pulse in the body. And yeah, it's working. So
Great.
It can be very, very easy procedure to measure cardiac output and total blood volume.
All right, great. Thank you very much, Pim. Thanks again for your presentation. We wish you, of course, all the best with this new startup. It looks very promising. We'll be going on to the next speaker that I have waiting here in the room. So let me quickly start this thing here. All right, and today we have here Eduardo Margallo or Margallo?
Perfect.
Yes?
No, Margallo is perfect.
Margallo, okay, from Ommatidia Lidar. So Eduardo is going to tell a bit more about his company, what they're doing, and I hope also that for you here, the Hannover Messe is doing well.
Yes, it's been a great Messe. It's been a great event with a lot of good meetings, and thanks to Photon Delta for the opportunity to showcase our product and also be part of this dialogues.
All right, and I'll give you the controls, and the floor is all yours.
Perfect, thanks, Jorn. Okay, so Ommatidia Lidar is a company in the field of 3D imaging and 3D metrology, and we rely on integrated optics to bring new performance levels to this market. The program we are focused on is the characterization of large-scale structures and products, both from a dynamic perspective, a structural dynamic perspective, and a dimensional metrology point of view. And what we are trying to address is the fact that existing systems are relatively complex. and often need installation of sensors on the structure or the use of markers that need to be moved around if you want to get good accuracy. Systems which are contactless normally suffer from insufficient accuracy, and that's how our solution fits in. So we are providing a contactless method to recover the shape of objects, which can be very large, up to 50 meters, and without any form of interaction with the object at a distance. We are able to deliver the highest standard in accuracy, comparable to what you can get with interferometric systems, which install sensors on the surface. And we are still able to deliver fast, effective data collection and the information about the dynamics of the structure, how it moves. So this is all provided by our first product on the market now, which is our Q1 multi-channel laser radar that we are presenting and demonstrating here in Hanover. We have 128 parallel channels provided by integrated optics that give interferometric absolute distance measurement with high accuracy. This is being used already by partners and customers in the aerospace industry, in production, for example, automotive production and civil engineering. So these are some of the partners we have been working with in the last months since we launched the product on the market in January this year. The European Space Agency, of course, with whom we have a project for in-orbit metrology. ADIF, a large operator of railway infrastructure in Spain, Airbus, TNO, INTA. And this is the type of studies we can do. We can scan large objects. This reflector for an anechoic chamber. It measures 14 times 9 meters, and we can just scan our beam array over the structure and recover the shape with precisions, accuracies below 0.1 millimeter. This is something they couldn't do before. This was characterized when it was manufactured with some calibrated parts in the US, but once it was shipped to Europe, there was no proper way to check the shape again. And the only way they had to see whether the reflector was still fine was look at the effect on the radio waves. So we have been working on full recovery of the surface and the full analysis with accuracy that's required. Beyond dimensional metrology, measuring the shape, we can also measure the vibration behavior of objects. So here we were measuring a footbridge as part of a larger project on structural health monitoring. And it's very clear we can see how the bridge vibrates when you operate one shaker that's mounted on the bridge. But also we can pick up the small vibrations that happen just because of ambient interactions. And the sensitivity is just as good as the best piezoelectric accelerometers that you would mount on the surface. Of course, the advantage here is it's contactless. You can do it from 20, 30, 40 meters distance, and you can just collect your data and you're ready to go. So here we have a Friday experiment with our device where we were scanning a guitar, which I find very funny, and also allows you to visualize what's possible with the technology. Maybe I need a bit of help with
what's going on here.
Okay, thank you.
Yes.
Yeah. So here we are waiting for about half a second because of the frequency resolution we wanted to have was about 1 2 Hertz. And you see the beam scanning the guitar. And what is interesting is that with this very simple method, you can immediately reveal the vibration modes of the guitar, right? The resonances. And this is what you can see on the right in the second video. Oops. Yeah. So each of the peaks corresponds to the resonance mode of the guitar. We can see where the sound is actually concentrated on the body. We can do this modal shape analysis also with large structures like bridges. We are applying this to a number of applications, also antennas for telecommunications, satellites, etc. And this is thanks to the very high accuracy that the system has. Okay. Yeah, this is another project. This is a railway bridge. It's a high-speed line. And here we were collecting data. We were doing just a very fast 3D scan just to get a sense of the range that we can achieve with the system. We are getting data from up to 80 meters here, but with good density, it goes up to 50 meters typically with good signal. And after acquiring this 3D plot at the bottom, we went under the bridge and we were measuring the deck of the bridge from underneath, projecting the 128 beams on the deck. And we are able to see, for example, the ambient vibration, which is important for the civil engineers to know whether the bridge is still healthy or needs to be repaired. We can also see, for example, in the upper graph, this is just a plot of the vibration level as a function of time horizontally, and you have the 128 channels vertically. So we are able to see when the train goes on the deck, and you can see a force vibration of 3 hertz here happening just because of the train, which then moves further along the bridge. And this is the type of bridge analysis that civil engineers would want to see, and they would focus mostly on these low frequencies, which are meaningful for them to understand whether the bridge is healthy or not. So in summary, our product has a number of advantages. It's a product that gives you both dimensional and structural metrology. It gives you very easy deployment. It's a portable equipment that you can take anywhere. It's affordable. It's not one of these, kind of super large installations for special locations. It can be used really in a number of settings. And we have this new functionality that gives you insights inside the structure, not just the surface, right? It's fast. We get measurements in seconds, and it gives you the highest accuracy that is now required by the industry. It's also very well connected with standard software for metrology, and we can either provide a license or work with the existing license of the customer. And if you're in Hanover, please come and visit us. We are in Hall 3 in the Dutch pavilion, stand A20. Our booth is B38 within it. And by all means, if you're interested in what we are doing, send us an email. We'll be happy to give you more information about our products, solutions, etc. Thank you.
All right. Thank you very much, Eduardo, for your presentation. Let me see if there's any questions popping in. I think so far not, but I might have one for you. Let me stop sharing the screen for now. All right, so you talked about the different applications that the product is being used right now. And you I said, okay, so for production in aerospace, automotive, civil engineering. I know also the latest iPhone even has some kind of Lidar in it. So what's your vision of the future of this technology? How do you think it will be implemented besides, of course, the things that you just mentioned?
Yeah, Lidar is a key technology for the digitalization of the world. And here we are presenting a product which has a very clear industrial focus. But indeed, there are other industries where Lidar will become very, very important. And that goes from communication devices, augmented reality, where you want to connect, right, a model to the real physical world you're seeing with high fidelity, to, of course, autonomous vehicles, robotics, and so on. So we have a development program which is significant, well-funded, running, really to miniaturize this technology and move it towards those markets. And the focus is, of course, on small size, cost reduction, and scalability in terms of high volume production.
And that's where also integrated photonics can have the added value, I guess.
Absolutely, yeah.
Yeah. All right. And maybe also I was thinking for 3D printing, this can be good to scan objects, right? Does the scanning need any calibration before if you install the unit?
Yeah, the system is calibrated when we do our final quality production and so on. And it has some self-calibration procedures when it boots, so that based on a few calibration points from the factory, we're able to ensure accuracy throughout all the operation conditions that you may encounter.
Okay.
So for example, something which is interesting is that the refractive index of air will change depending on temperature and depending on humidity, atmospheric pressure. So we have an atmospheric unit inside the device to compensate for all of that. So all these minor things need to be taken into account, and of course they are inside.
All right, so it's really just a plug and play solution. You don't have to calibrate it every time you want to use it. It automatically does it, kind of.
Yeah, startup time is typically a couple of minutes. That's a stabilization time for the laser and the self-calibration routine. And from then on, you can just measure.
All right, great. Well, if there's no further questions, I would like to thank you very much for your time, Eduardo, and wish you, of course, just like Marangelo, also all the best at the exhibition. And I'm sure we'll meet later again.
Thanks a lot, Jorn. Thanks to everyone for your attention.
Okay, thank you. So I will start again the Okay, so next is the keynote, and this time we asked Nick Singh, the new CTO from PhotonFirst, to share with us some of his insights, his experience, and his vision on the integrated photonics industry, but also on what PhotonFirst is doing. In order to do that, we recorded a little Q&A with him that we would like to share with you. Nick, unfortunately, is not able to be here today in the session live, but if you have any questions, still drop them in the chat, and we'll be forwarding them to him, and he will get back to you. So, with no further ado, I would like to start.
Yeah, I'm Nick Singh. I'm the CTO of PhotonFirst. I joined PhotonFirst in February this year. My background is basically in IEEE, which is essentially electrical engineering, electronics, automatic control systems, and I also qualified with physics. Plasma physics, which was a route towards the chip industry, essentially. So I spent a lot of time working in the semicon industry, and now the early days of the boom and bust of the photonics life, because I was hired to work on photonics systems. And then we had the bubble burst. So we had a system which was used to deposit and etch planar waveguides. So we were doing all those in conjunction with all these wonderful customers we had at the time, like JDS Uniphase, Caswell, Marconi Space, etc. So I was very familiar with that. And I was always working on high tech. I've always spent quite a lot of time, more than 25 years, working on high tech most of the time, bringing products to market. So having some successes. So I spent the early part of my professional career was with the medical devices industry. So bringing ENT type systems to market. And after a decade in the semicon space, I was contacted by somebody I knew who said, "Oh, would you be interested in working in what he call is ultra high vacuum and space applications and things like that?" So I said, "Okay, yeah, why not?" So I managed to join another business. They were specializing in instrumentation, scientific instrumentation. Yeah, and then I mean, having done all those loops, and I was operating at a higher level, so as a CTO, group CTO, executive CTO level. So I'd done most of the loops. I was more interested in trying to close the loop in a way by working with startups. So I joined a startup on an interesting project, which was at the time I was keen on renewables and clean tech, which was more to do with trying to produce water. It was a noble cause, as you know, renewables, circular economy. Somebody said that the next war would be fought over water, and that was, I think, John F. Kennedy. I think he said it a while ago, I believe. So it seemed like a novel idea. So we managed to find a process where we could produce water without boiling and at atmospheric pressure. So that always excited people. How do you do that? How can you do that? So you end up having something dirty going into a system and coming out clean, pristine, and with a bit of treatment could be turned into drinking water. So that was quite exciting. And so having done all those loops at that time, I was coming towards what else to do next. And there was this exciting opportunity of photonics. I said, oh, it's like going back to my original roots in a way. And I thought about it, and it sounded like an interesting way of bringing sensors to market, and hence I joined PhotonFirst in February. So since then, I've been obviously trying to figure out how do we make penetration in a market which is still emerging. There are lots of interest, and we have some wonderful technology, and we got some very highly skilled people, and obviously helping, looking forward to the next generation with trying to move towards miniaturization. And actually, you know, it would be nice to have a very small form factor system. That's the holy grail of photonic sensing, and something I'm very keen on developing with the team. So we are looking at roadmaps, and we have partners in the Photon Delta ecosystem. For example, Smart Photonics. We're working quite intimately with them to develop some next generation chip designs, etc. And I think we can, you know, make a big significant impact, especially with systems or sensing solutions which have a low form factor, what they call C-swap, costs, size, weight, and power, and no CO2 emissions as well. So applications like energy, batteries, transformers, those are some of the key areas I think PhotonFirst can play a significant role. My take on that is that they will go together. They're like, I wouldn't say husband and wife, but you know, you need optics, you need electronics as well. So I think the hybrid integration is the way forward, and that's actually what will happen, I think, and that's going to take, you know, precedence or prime over the next few years. The issue with photonics is that you have what you call is optical functions, whereas you know, it's much easier to do passives, capacitors, resistors, transistors, switching devices with, you know, silicon-based circuits, and because a lot of experience in that over the years. It's a mature industry. It's maturing now. Whereas photonics isn't there yet. It needs a lot of work. But I think it's important to get skills transferred from the semicon industry into the photonics industry, which is, I believe that currently there are quite a few shortages in terms of people and skills as well, which is unfortunately slowing down the acceptance of photonics based systems essentially. But I can see photonics going down the same sort of road, because it's also driven by data now. So data centers, that's, you know, silicon photonics is paving the way. And obviously, we are not far off from the 400 gigabytes per second. I think at some point that's going to happen. So, you know, naturally this will lift or pull, you know, the indium phosphide photonics and other hybrid platforms towards that goal. But obviously, the important bit, I think, is to work as a consortia, as partners, more than saying, okay, I'm a customer, I'm a supplier. I think there's lessons to be learned from those who make the devices, those who develop the processes, and those who actually apply the processes and devices into sensing systems. So I think there needs to be a lot more collaboration. I think in the Netherlands, I think that's happening quite a lot, and Photon Delta is playing an important role. And obviously, that role is evolving with obviously the latest announcements of investment. So I think we're on the right track. But there is still some work to do, obviously. Well, I think what is becoming more crucial and important is the user experience. And over the years, obviously, given the advent, obviously, the silicon industry, you know, drove that gaming experience, virtual reality, augmented reality, all that. And so that's driving a hunger for data. So the data is going to become currency, and it's going to dictate your life, I think, because that's the way it's heading. So maybe you'll end up like photonics sensor on your body, which tells you how much sweat what is the sweat and what's in the sweat, and you're lacking calcium or magnesium, and it prompts you and saying, hey, go and take your daily dose of magnesium, for example. So I can see those things coming into play. Photonic sensing moving more towards the consumer market because it can do quite a lot of things. And that's when the size, the form factor becomes quite important. So similar to, what do you call that, the Apple Watches and things like that. So at least you know what's happening and you're running, you know your heartbeat, you know what to do. You can, I think it will become very consumer driven essentially. Well, I think there are two aspects to this. One is obviously we need to have the technology building blocks so that we can move towards C-swap essentially, which is cost, size, weight, and low power. But at the same time, I think we are working on very specific applications as well. So looking at the sensor end, where, how do we make sure that a fiber, because we use a fiber as a sensing point with fiber break ratings and maybe some other types of systems, how do we adapt it to what the user needs to? Because the fiber optics essentially hasn't, as the technology hasn't really evolved. It's been there for a while. It works, yeah, great. But I think there's so much you could do with that, in the way you print your gratings, the way there's a lot of things I think needs to be done there. So hopefully we will be spending some time on that as well. I think because the ecosystem is, let's say, fairly immature, it's still young and developing. So, technology takes a long time to turn into product, right? It's 10 years plus sometimes. I think there has to be some level of maturity now with a bit more experience and a bit more investment. So it would be nice to see, I think, what I would call an increase in professionalism as well. Maybe that's been lacking. It has been perhaps a bit more R&D focused. So I think there has to be a transition at some point where, well, how do we, turn those into a proper commercial entity, essentially. So I think there's lessons to be learned there, and how to work with your own ecosystem partners, which sometimes have been, there's been a mismatch between requirements. Say, for example, we are a commercial entity. How do you make sure that our requirements are met in timely manner with proper communication and all this usual good stuff, which maybe it's down to, it's much easier to attract talent in the Valley, right? It's much harder in the Netherlands. And so, yeah, I think a lack of, I think it needs to have more diversity in the workplace as well. But as I see the technology evolving, I think there's no reason why we can tap into what's already being done in silicon photonics as well. So there might be opportunities in terms of partnering. Transceivers and receivers operate at very fast speeds as well, and there's something to be done there. At the same time, there's the packaging side, the industrialization side, which is we have some experience, but that's something we would like to obviously progress further. So I'm also quite a fan of quantum computing as well. I know it's not a volume application, it's still niche and high tech. So I would like to perhaps at some point contact the guys in Untitled, is it? They're working on, so it'd be nice. They do all these nice promotions, and then you go and listen to their talks, and it would be nice to develop some of this relationship, because I think it's a joint forces approach which will take us there. And if you work in isolation, it's not going to work. So I think because it's deep tech, we are in deep tech, and deep tech always requires more investment than you have to. I've already started reaching out to a few of the other members in the ecosystem. And over the next sort of 2-3 months, I plan to visit a few of those as well. Also was lucky enough to be part of the Photon Delta, the Renault visited Photon Delta, so it was nice to show them what our technology could do. So it'd be nice to be part of a few missions like that if the Dutch cluster goes overseas. At the moment, I'm sort of still commuting between the Netherlands and Bristol. So I've been lucky enough to have a boss who's allowed me to do that. But it sort of works, because I've realized with the new way of working, you can focus on the strategic side as well as the tactical side, because otherwise you spend all the day in meetings, which is a necessary evil. But I live in Bristol, so it's only an hour's flight from Bristol to Amsterdam. So yeah, that's not an issue. But it'd be nice to spend more time in Alkmaar and the Netherlands and get to know people, because that cannot be replaced by virtual meetings and so forth. But I think if you take on professionals who have significant experience, I think it's doable, entirely doable, and they don't have to be there. I think also that depends on your management style or leadership style as well. That's quite useful. And I think, yeah, so I think it's entirely feasible and achievable and doable to work remotely and while spending core days or key days with the team and allowing them to have some breathing space as well, whilst fostering a culture of empowerment, which is quite important as well, especially when you work with knowledge workers, essentially. So I think you don't want to be behind and micromanaging and all that, which is not the way the world works nowadays with the millennials. So I think it's a different way. Life is changing. I know you sometimes feel the urge to be there all the time, but I think sometimes it's better to pull back a bit, because instead of being reactive, if you take a few seconds off and do something, you can make a much better decision. Well, I think the work, I mean, nowadays working, it's a global works world, isn't it? So the world is, as I say, shrinking. So I think there's talent there. I think the important thing is to get the right talent in the business, which helps drive the business forward. I believe the Netherlands is actually quite good at that. I think with ASML hiring lots of workers from overseas. Yeah, I think that's quite, given the size of the economy and so forth. I think you have to be pragmatic, essentially. So I think that's quite useful, and there's talent out there, and people are always getting smarter and learning new skills, and I think it's a travesty if you don't try to capitalize on that or try to encourage that as well.
All right. Well, everyone, we are a little bit over time, and I would like to thank Nick for his contribution to today's session as well. If you have any questions, drop them in the chat. I'll be able to forward them to him. But of course, before finalizing and concluding this session, if you have any feedback on how we should approach and how we can make this of more added value to you as the community, just scan the QR code or go to our website. That's where you can fill out a form. If you go on the event section, Delta Dialogues, you can find the form to help us improve this and make this better for you. Also, you can contribute to next session. If you have any nice presentation or you have some challenges you would like to share, you would like to get insights from the community, use that same form to submit those questions or presentations. And who knows, I will be contacting you next time to do your presentation. Next edition will be on the first Wednesday of July, which is the 6th. So do not forget to sign up, and we'll see you there. Thank you very much, and see you next time.